All welcome to online lecture series on Laplace transforms, lecture number 10. In this lecture we'll solve some problems using the property of first shift property and multiplication by t power n. Before that, first let me recall the property of multiplication by n, which states that Laplace transform of t power n into f of t is equals to minus 1 whole power n nth derivative of L of f of t with respect to s for n is equals to 1, 2, 3 and so on. So for n is equal to 1, we get L of t times f of t is equals to minus d by ds of L of f of t. For n is equal to 2, we get L of t square into f of t is equals to d square by ds square of L of f of t. For n is equal to 3, we get L of t cube into f of t is minus d cube by ds cube of L of f of t. So now let us use this property to solve some problems. Here we are asked to evaluate L of t into e power 2t into sin 3t. So if we observe the function here, we have three terms t, e power 2t, sin 3t. So we should get an idea that we should apply two properties here. One is first shift property because we have e power 2t here, and second one is t times f of t because we have t here. So here we use two properties. First one is the first shift property, which states that L of e power at into f of t is L of f of t with s replaced with s minus a. And the second property is L of t times f of t is equals to minus d by ds of L of f of t, because here in this function we have t into some function and e power at into some function. So now let us consider the given function L of t into e power 2t into sin 3t. We can write it as L of e power 2t into t sin 3t. So this is of the form L of e power at into f of t. It is of the form L of e power at into f of t here. This is f of t in this case. E power at is e power 2t. So here we use first shift property, which states that this is equals to L of t sin 3t, where s is replaced with s minus 2. So first we should evaluate L of t sin 3t and then we replace s with s minus 2. So first we have to evaluate this inner term L of t sin 3t. So to evaluate L of t sin 3t, we use this property. What is L of t into f of t? Minus d by ds of L of f of t. Therefore, L of t into sin 3t is minus d by ds of L of sin 3t. So it is equals to minus d by ds of L of sin 3t. And of course, we should replace s with s minus 2 after completely evaluating the inner term. So what is L of sin 3t? It is 3 by s square plus 9. So that it is equals to minus d by ds of 3 by s square plus 9, where s should be replaced with s minus 2. 3 here, 3 is constant here. So here 3 is constant, so it can be taken outside, and 1 by s square plus 9 can be written as s square plus 9 whole power minus 1, and its derivative is minus 1 into s square plus 9 whole power minus 2 into internal derivative. Derivative of s square plus 9 gives 2s, where s is replaced with s minus 2. So now multiplying 2s minus 1 and minus 3, we get 6s, and s square plus 9 whole power minus 2 gives s square plus 9 whole square, where s is replaced with s minus 2. So because the internal term is completely simplified, now we can replace s with s minus 2. So we write s minus 2 in place of s. Therefore that gives 6 into s minus 2 by s minus 2 whole square plus 9 whole square. That is 6 into s minus 2 divided by s minus 2 whole square is s square minus 4s plus 4 plus 9, that is plus 13 whole square here in the last term. So therefore L of t into e power 2t into sin 3t is this one. 6 into s minus 2 by s square minus 4s plus 13 whole square. Let us look into the second one. evaluate L of t square into e power minus 2t into cos t. Here also we need to apply two properties, because here we have t square into some function and e power at into some function. So we use these two properties. L of e power minus at into f of t is L of f of t, where s is replaced with s plus a because we have minus at here, which is first shift property. And L of t square into f of t is d square by ds square of L of f of t. So we can apply these two properties one by one. First we can use the first shift property, then L of t square into f of t. Or if you wish, first you can apply L of t square into f of t property here and then first shift property. So anything gives the same solution, same answer. So we consider L of t square into e power minus 2t into cos t. First I apply first shift property, that is more comfortable for me. So it's your wish. You can first apply L of t square into f of t property first, or first shift property first. So here I use first shift property first, so that this is of the form L of e power minus at into f of t. L of e power minus at into f of t is here t square into cos t. So using this first shift property, this becomes L of t square cos t, where s is replaced with L of s plus 2. Now we first evaluate this internal Laplace transform first, and then we replace s with s plus 2. So now we need to evaluate L of t square cos t. Using this property we do that. What is L of t square cos t? It is d square by ds square of L of cos t, where s should be replaced with s plus 2. Now first we will find L of cos t. What is L of cos t? It is s by s square plus 1. Now we should differentiate it 2 times, because we have d square by ds square here. So this gives d square by ds square of s by s square plus 1, where s is replaced with s plus 2. So first let us differentiate one time. D by ds of s by s square plus 1. We use u by v, derivative of u by v rule, which is d by ds of, here u by v, derivative of u by v is equals to v into u dash minus u into v dash by v square. U is here s and v is s square plus 1. So applying this property, this formula, we get s square plus 1 into derivative of u, that is s, is 1. So v, this is v into u dash minus u is s into v dash, that is derivative of s square plus 1 is 2s, by v square is s square plus 1 whole square, where s is replaced with s plus 2. So simplifying the numerator, we get s square plus 1 minus 2s square. S square plus 1 minus 2s square, that gives 1 minus s square by s square plus 1 whole square. So totally it is d by ds of 1 minus s square by s square plus 1 whole square, where s is replaced with s plus 2. Now let us again differentiate this with respect to s, applying u by v formula again. Derivative of u by v is derivative of v into derivative of u, that is s square plus 1 whole square into derivative of u is minus 2s minus u into derivative of v, that is 1 minus s square into derivative of s square plus 1 whole square is 2 into s square plus 1 into 2s by s square plus 1 whole power 4. So now we have s square plus 1 common in the numerator, and we can cancel it with the denominator. S square plus 1 is there here and here, so we take it common and we cancel with the s square plus 1 term in the denominator, so that we get minus 2s into s square plus 1 minus 1 minus s square into, because this s square plus 1 is cancelled, we have 2 into 2, 4s here. So now just multiply and simplify this. Then we get 2s into s square minus 3 by s square plus 1 whole cube, where s must be replaced with s plus 2. Now because we have entirely simplified the internal term, now we can replace s with s plus 2. Now replacing s with s plus 2, we get 2 into s plus 2 into s plus 2 whole square minus 3 by s plus 2 whole square plus 1. Just expand the whole square terms and simplify. You get 2 into s plus 2 into s square plus 4s plus 4 minus 3, that is plus 1, by denominator is s square plus 4s plus 4 plus 1, that is plus 5 whole cube. Therefore, L of t square e power minus 2t into cos t gives 2 into s plus 2 into s square plus 4s plus 1 by s square plus 4s plus 5 whole cube. Here what you need to apply is, we applied first shift property for t square into cos t and L of t square into f of t property for cos t. So we use two properties here, multiplication by t power n and first shift property. You can apply any of the property first and second one later. Next we will go to another problem, similar problem. Evaluate L of t square into e power minus t into cos square t. So again we have L of t square into f of t and e power a t into f of t also. So we use both the properties here. Using these properties, we can write L of t square into e power minus t into cos square t as first. Here I apply first shift property here. This one, first shift property. Then I can write this as L of e power minus t into t square cos square t. L of e power minus t into t square cos square t from this formula is L of t square cos square t, where s is replaced with s plus 1. Now first we evaluate this L of t square into cos square t. For that we apply this property, L of t square into f of t property. So applying that property, we get d square by ds square of L of cos square t. d square by ds square of L of cos square t, where s should be replaced with s plus 1. So now we cannot directly evaluate Laplace transform of cos square t. So for that we write cos square t as 1 plus cos 2t by 2. So now if we use linear property for Laplace transform here, we can take this 2 outside and we can split the Laplace transform as L of 1 plus L of cos 2t. So that gives d square by ds square of L of 1 plus L of cos 2t, where 2 is taken outside in the denominator, and s should be replaced with s plus 1. So that is d square by ds square of, we know that L of 1 is 1 by s and L of cos 2t is s by s square plus 4. So we have to find two derivatives for this term, and after that we have to replace s with s plus 1. So first let us find two derivatives, first one derivative and later the second derivative. So finding out one derivative, what is derivative of 1 by s? Derivative of 1 by s is minus 1 by s square, plus derivative of s by s square, applying again the same formula, derivative of u by v is equals to v into u dash minus u into v dash by v square. We get 4 minus s square by s square plus 4 whole square. So after evaluating one derivative, we got this term. Now let us find its second derivative. Derivative of minus 1 by s square is a derivative of s power minus 2. Derivative of s power minus 2 is equals to minus 2 into s power minus 2 minus 1, that is s power minus 3. So it is 2 by s cube. And here we use again u by v derivative formula. What is that? V into, this is v into u dash. U dash is 2s here, minus u into, that is 4 minus s square, into derivative of s square plus 4 whole square is 2 into s square plus 4 whole square into internal derivative is 2s. Now the matter is just simplification, multiplication and simplification, and then finally replacing s with s plus 1. So that gives 1 by 2 times 2 by s cube, plus cancelling 1 s square plus 1 in the second term. In this term, if we cancel 1 s square plus 1, we will get this. And now if we multiply and simplify, that gives 1 by 2 times 2 by s cube plus 2s into s square minus 12 by s square plus 4 whole cube. Now we can replace s with s plus 1. So after replacing, we get 1 by 2 times 2 by s plus 1 whole cube plus 2 into s plus 1 into s plus 1 whole square minus 12. That gives s square plus 2s minus 11 divided by s plus 1 whole square plus 4. That gives s square plus 2s plus 5 whole cube. Therefore, we evaluated the given Laplace transform of given function. Now let us find Laplace transform of t into e power t into sin ht. Sin ht we can write it in terms of exponential function as sin hx is equal to e power x minus e power minus x by 2. So in the given function sin ht can be written as e power t minus e power minus t by 2. So this sin ht is written as e power t minus e power minus t by 2. Now if we multiply this t into e power t with each of the terms, we get, first if we multiply with e power t into e power t gives e power 2t minus. Now if we multiply with the second term, we get t into e power minus t is e power 0, that is 1. Therefore, this gives L of t into e power 2t minus t. 1 by 2 is anyway constant, it can be taken outside. So now using linear property, we can separate this as 1 by 2 times L of t e power 2t minus L of t. L of t we can directly write it as 1 by s square. But to find L of t into e power 2t, you can either apply first shift property or you can apply multiplication with t. You can use any of the property. So here I use first shift property because it is simple to apply. So using first shift property for the first term, we get L of t where s is replaced with s minus 2 minus L of t. What is L of t? It is 1 by s square. In the first term, we should replace s with s minus 2. And second term, no replacement, it is just 1 by s square. So in the first term, if we replace s with s minus 2, we get 1 by 2 times 1 by s minus 2 whole square minus 1 by s square. Taking LCM and simplifying, we get finally as 2 times s minus 1 by s square into s minus 2 whole square. So here we applied first shift property in this case, in the first term. If you want, you can apply L of t into f of t also. It also gives the same answer. So these are some practice questions for you. Evaluate L of t into e power minus t into sin t. Evaluate L of t cube into cos a t. T cube into f of t is minus d cube by ds cube of L of f of t. 3 times derivative, minus times 3 times derivative of L of f of t is cos a t here. So you need to differentiate 3 times. Next one is evaluate t into e power 2t into cos 2t. Here also you need to apply first shift property and then t into f of t. First shift property and then t into f of t. And you can also try this. Evaluate t square into e power minus 2t into sin square 2t. Similar as fourth problem we have discussed here. There we have cos square t. Here we have sin square t. Sin square 2t can be written as 1 minus cos 4t by 2. So try these problems. If you have any doubts or queries, you can contact me. Thank you for watching the video. Keep learning.